When we talk about linear to circular, from a straight line to a circle, we make this circular economy idea sound really simple, and one of the things that appeals to me is that in essence it is. The first things that I learned about circular economy is this idea of it being made of two different types of material, technical and biological. So firstly, technical, what is the technical cycle?
Technical cycle is basically anything that doesn't biodegrade. So it would be metals, rare earth metals, most plastics, polymers, things that you would want to recover within a circular economy and feed back into the system. It could be through recycling, that could be chemical recycling, it could be physical recycling, anything that doesn't biodegrade. And the biological cycle is the side of the circular economy that would biodegrade. Now you could think of that as being, food or wood, but it's very, very broad. It could be cotton. It could be a form of wood which is chipboard. It could be anything that, if it's designed correctly, which is also very important, would physically biodegrade and return to the soil. And it's very important to distinguish between the two, because the technical materials you want to recover and feed back into the economy. You can't let those lie on the ground and disappear, because they won't, apart from perhaps some metals will eventually rust away. But they're very valuable. The biological cycle is valuable in a different way, because it's biological material which for billions of years has been returning to the earth and regenerating soil, and actually we've kind of broken that cycle with timber, with cotton, with food waste, with human waste. We're not returning that to the soil and regenerating cycles. So you think of those two, technical and biological cycles.
And today one of the problems is we mix those things up.
We mix them up all the time.
We combine biological materials with technical materials in ways that they can't be separated.
Clothing would be a great example with a polycotton. We can't recover those two different fibres. They're all woven together.
You mentioned recycling. How is it part of circular economy?
Well, recycling really, yes, you want to do it, absolutely. Of course we want to get the materials and feed them back into the system. But it's almost the loop of last resort. Most of the value in a phone, for example, is the phone. Of course the components have value, and of course the materials have value, and you want to recover them at the end of the life of that phone, but actually the phone itself has the most value. So yes, we want to recycle, and packaging would be an example of a very high volume, low value material that you would want to design to be 100% recyclable if it were plastic, for example. But then you also have these other products that sit in a different space where you want to keep them as the product for as long as possible.
So in essence, if you have to make something again, that surely takes more money, energy.
Absolutely. And I think a great example of that is remanufactured engines. Well, if you think about making an engine, for example, that engine is a phenomenal piece of equipment that's had millions of hours of R&D put into it, and it works. Most remanufactured engines today have actually broken. They come into a factory having been broken, they get completely stripped down, ultrasonically cleaned, and then the majority of the parts get reassembled into a new engine. About 80% of the original parts are in the new engine, the remanufactured engine, 20% will be replacement parts. But that engine then has 80% less energy and 80% less material in it compared to a new one. So you're saving so much money and resource through keeping it in the system. Now that's a broken engine. If you can predict when an engine's about to break and then remanufacture it before it breaks, you'll be changing much, much, much smaller parts. And if you design it for that, then it'll be a much cleverer system. When you look at cars today, they're parked the majority of the time. Over 90% of the time, the car is just parked, not being used. And then when it is used, the majority of the time, it's got one or two people in it. So within a circular economy, of course, you would design the car so you can remanufacture it, so you can disassemble it, so you could recover the materials. But we probably wouldn't own it. We'd probably have access to it somehow, either leasing it, or you would pay per mile, or like Zipcar or Streetcar. There are so many examples now, particularly in cities where more and more people are living, whereby you have access to this car. And once the car isn't yours and you don't physically buy it, then almost the manufacturer's incentivized to build a slightly different car, because they don't want to build it as cheaply as possible to sell, because they only make money when they sell another car. They want to make a car that works, that's remanufacturable, that they can recover the materials from, because they're probably leasing that into a system. They will get that back. They will want to be able to get as much value out of that for the second cycle or the third cycle as possible.
Okay, from remanufacturing, what about things like repair and maintenance? Are they the next level up?
Well, repair and maintenance keep things in use at their highest level. If you can catch something before it breaks, that would clearly be the right thing to do before you have a catastrophic failure that needs a remanufacture of that engine, for example. So yes, repair is absolutely part of a circular economy. That could be a phone, it could be a car, it could be clothing. How can you keep that thing that's been made with the energy and materials in it in use for as long as possible? It's definitely a growing industry. You know, several times I've repaired my phone, taken it apart, followed the instructions. It takes a couple of hours, but actually by the time you've gone off and taken the phone somewhere and paid someone else to do it and gone back and collected it and not had your phone for a while, it's actually quite inconvenient. And I think there are people who would love to fix it themselves. There are other people who absolutely don't want to do that. So there are different options, but it's great to see this space growing.
Then lastly on this technical cycle, sharing is part of the picture, and it could be related to some of the other loops that we just mentioned, but we're seeing more people share the products that they own.
Well, if you think about a power drill, you know, most people have one in the home, but most people hardly ever use it, and it's generally not a very high quality drill, and it will probably break when you've used it just a few times because it's bottom end of the market. And you can take that to the next level with China, with Y-Closet. You know, you effectively lease your clothes, you're sharing your clothes with other people, but you don't think of it like that. You're leasing them, you're having this phenomenal box of great clothes delivered to your home, and then off it goes. And so sharing doesn't just have to be between you and your neighbour or you and someone down the road. It can actually be done in a much more sophisticated manner.
So that's the technical cycle, things like repair, remanufacturing, recycling. What about the biological cycle? Because the routes are going to be quite different if we want to make use of all the materials and value within that cycle. You can't rent or repair a sandwich.
Not really, but if you think of the principles, they're very similar. So technical products, keep them in use for as long as possible. You know, think about this building. This is timber. This has been in use since the 1500s. This is being kept at a very high quality because it's doing a very important job. That could have been burnt in the 1500s and then it would have been very low quality very quickly, albeit doing a useful job. So if you think about applying that to today's economy, a piece of timber could be burnt, which we do in many countries, or that piece of timber could be made into a table. At the end of the life of that table, the table could be broken down and turned into particle board. At the end of the life of that particle board, it could be broken down and it could turn into compost if it was intelligently designed. So think about what we call cascading. How can you use the item you have for as long as possible? It could be said for cotton. You could make a t-shirt, that t-shirt could become wadding or stuffing or padding or sound insulation, and then eventually, if it's non-toxic, organic and biodegradable, it could feed back into that biological system. So it's not just the biodegradable things we think of, like food waste or human waste or leaves from trees. It's also the bigger things, these things and the fibres. How can we keep those in use for as long as possible? How can we keep them at their highest value? So many loops, so many innovations, and a different way of thinking. If you put a toxic ink on a piece of paper when you print it, then actually you can't really recycle that paper and turn it into, a cereal box, for example. So think about how you design. Think about what system you're designing for.
And on the biological cycle, people often talk about things being regenerative or regenerating natural systems. What do we mean by regenerative, and why is it such an important part of that biological story?
I see, regeneration as an opportunity. We've been so extractive and so consumptive for so many years. We talk about, 60 harvests left before topsoil degradation means we can't really grow anything in the way we do today. I mean, that's quite critical. But if you can collect all the biological material, the human waste, the food production waste, and feed that back into the system, you have the ability to regenerate it. In today's world, there's a phenomenal opportunity. We're so used to thinking, let's just make this last a bit longer, let's eke out what we've got a bit longer. But this is a completely different way of thinking. Let's actually make it better. Let's regenerate it. Let's make it richer. Let's make it hold more water. Let's make it better land.
It's that flipped perception from how can we just minimise the negative impacts to how can we
build something better,
to have a positive impact with all the different activities that are going on in the economy every day.
Absolutely. It's a completely different mindset.